Alright, so these are going to be our notes on torque. As we've done with all the other units too, we've kind of looked at them as just measurements of like velocity, acceleration, and then in the end we looked at force, and that's kind of what we're doing here. So we're looking at rotational motion and gravity and Kepler's laws, and now we're looking at the idea of how does a force make something rotate about an axis. So if we have like a seesaw or something, or even let me change that. Even if we had like a propeller on a plane, how does that work? How does that force cause that to spin? And that force that causes the spin of an object around an object or around a central axis, we measure that in torque. You see here, torque is the ability of a force to rotate an object around an axis. So we see that with propellers, we see that merry-go-rounds, anything that's going in a circular path around an axis, that ability to cause that to happen is called torque. Okay, and the equation for torque is torque equals force applied, F, times the length of the lever arm, and we'll talk about that in a minute. And if there's an angle into it, you add the sine of the angle. So, for instance, let's say we have like a lug nut on a car, and we want to get it loose. Well, we put a wrench on it, and we then apply a force. Let me redo that thing. So let's see if I can get better. Okay, so then we have this, and we make this little wrench around it here. We can probably like make it a little bit so it's not so. And so we have this force, and we want to take this lug nut off. So we're going to apply a force, and we could apply a force here. We could apply a force way on the end, and so on. We could even take a cheater bar, put it on, and make the force extend even more further out. And that may help you kind of understand why people do that. And so the equation is the force you applied. So let's say it's always 10 newtons. So you apply 10 newtons here, you apply 10 newtons here, and you apply 10 newtons here. You'll be able to see that last part. Let me push it out there a little bit. Maybe I can, I don't know, maybe not. Okay, so the difference is here we're timesing this. So depending on the length of this, you're going to get more torque out of it. Or it's like a little lowercase t is actually what you get. So if we know the force 10, then we just measure from this central point. So you have measurement A, and then you might have measurement B, okay, and then maybe even C, which is even further. Okay, but you can see how adding distance to something increases your torque and increases the ability to loosen this thing and make it turn in a circle. So that's why people do that. So if you've ever worked on a car and you want to get a tire lug nut off, you can't get it off, you put a bar on it, make it even longer, and that increases the force, not really the force, but it increases the torque that you can apply to something. Okay, as you see here, torque depends on the force. So if you want to increase torque, you can also increase the force. So 10 newtons, 20 newtons, 30 newtons, that's going to increase the amount of torque. Okay, but it also includes, or it also is dependent upon the lever arm. So the longer gives you more torque. So the longer this becomes, torque goes up. Okay. And then the angle as well. So depending on the angle that you're using, that can also have a big factor in how much force you get out of it. So if I erase these a little bit, we'll kind of fix this up a little bit. I'll just redo this. So if I had a lug nut or something I wanted to get off, and you should probably try this yourself sometime, and you'd probably see the difference. Maybe you've never thought about it before. Come on. Okay. And then we put this wrench on here, right? Okay. And you'll notice that the best angle is straight up and down. Okay, 90 degrees. So to the spin of the axle. So this is your plane of where the axis is, and then you 90 degrees to that. That's your best deal. You're going to get the most power. So if you put 20 newtons here, that's going to give you the most torque. But as you go and put it at more of an angle, what happens is torque goes down. And that's from the fact that if it's at an angle like this, we know as we're pushing at this angle, we have some going this way and some going that way. It's like a vector. So you're losing some of this force as you put it at an angle. So force really, or angle, I'm sorry, really has a big influence on how much torque you get. So let me move down here now. So, and when we look at torque as well, direction. So if it's going clockwise, so if we're tightening something, we call that negative. And then clockwise or counterclockwise is loosening, we call that positive, which might not make much sense to you, but that's the way it goes. Okay, and then you have this term called torque net, and that's the sum of all forces acting on something. This might not make sense to you, but if you think about it, okay, a seesaw is a good example of this. So if you have a child sitting on here, and they're holding on to the bar, then you have a child on the other side, and they're hanging on to the bar. Maybe they're a little bit smaller. Okay, and when this child sits here, they apply a force down. Okay, and this force could be like this, and that's torque, because there's the axis. Here is your lever arm, this part here, and then you're applying the force. So F times L, you have a torque. But also on this side, you also have a different one. We'll make it pink. At the same time, this is a force that's going down, and but you also have this lever arm as well. So F times L, and you also have T2. And then whatever happens here, whether this torque compared to this torque, that determines what this thing does. So if this torque is greater, this will continue to go down. This one will be forced up. If this torque is greater, this one will go down, and this one will go up. It really depends on, and that's how you get propeller to work, or any object that spins around a central axis, by applying forces to it. And that's kind of your torque notes. Not a lot to them, but let me know if you have any questions. Try the problems in the book. They shouldn't be too hard. And let me know if you have any questions.